There are a few things we need to understand about each class interval. Take the first class 1 to 5 for instance. This includes all who have scored between 1 and 5, both included. The class starts with a 1 and ends with a 5. The numbers 1 and 5 are called class limits. If we have a class interval 6 to 10, then 6 and 10 are the class limits. In the first class, 1 is called the lower class limit and 5 is called the upper class limit. If there are 4 students who have scored between 1 and 5, then 4 is called the frequency of this class interval. Consider the first two class intervals, 1 to 5 and 6 to 10. They are called continuous class intervals. They are called continuous as one comes immediately after the other. 6 to 10 and 11 to 15 will also be continuous class intervals. The difference between the lower class limits of two continuous intervals is called the class width. 6 is the lower class limit of this interval and 1 is the lower class limit of this interval. So 6 minus 1, which equals 5, will be the class width. Class width may also be defined as the difference of the upper class limits. That is 10 minus 5. Consider the interval 1 to 5. The class mark is defined as the average of the lower and upper class limits of that interval. So class mark for this interval will be 1 plus 5 divided by 2. That will equal 3. So 3 is the class mark for this interval. Now look at the second interval 6 to 10. The class mark will equal 6 plus 10 divided by 2. That will equal 8. Look at the two class marks of the two continuous intervals. The difference between the class marks of two continuous intervals is also equal to the class width. If we consider these two continuous intervals, 8 minus 3 will be our class width. A class mark is for a particular class interval, and a class width is the same for the entire group of intervals. But wait, we need to understand something really important. So our class intervals look like this: 1 to 5, 6 to 10, 11 to 15, and so on. What if we have a number like 5.5 in our data? In which interval would it fit in? Well, it won't fit in any. How about we try a new way to make intervals? 1 to 5, 5 to 9, 9 to 13, and so on. What's so particular about these intervals? If you observe closely, the upper class limit of one class is equal to the lower class limit of the next class. Advantage? The number 5.5 will be included in this interval. This kind of grouping is called as the continuous form of grouping. The upper class limit of one class is equal to the lower class limit of the next class.